Gareth Moorhead here to talk about, the last of the scientists. I'm not sure, Mike, are you putting your hand up as a scientist or more as a business person?
I'm not a scientist.
Not a scientist. So our next speaker and last scientist, Gareth Moorhead, here to talk about micro and nano fab techniques creating high value add products. Gareth.
So I'm very lucky that I had my client here to give some introduction to our group. Chris showed you integrated systems, fully engineered, that are meeting particular applications, and we've worked on many of those in industrial machine vision and infrastructure management over the years. It's kind of the national interest projects that a big lab like CSIRO would do. Now we're looking very much at what can we do with the modern technologies, and you've heard about additive manufacturing, you've heard about 3D printing, printable electronics and so on. These are all technologies which are actually bringing a lot of creativity and design that's using very high-tech materials to technologists and people are interested in creating consumer products and so on. So we're looking at that field. That's becoming a very large economic driver in the world at the moment. So given that a fab lab for integrated circuits costs upwards of $1 billion, it's really out of reach of your average startup. So one way to do that is to go out and buy a $200 development board from Xilinx and get almost the same performance, okay, for a one-off device. And that allows you to do your prototyping, your proof of concept, your fit for purpose, and attract your venture capital. And eventually, if your product's very successful, you might go to a production run of integrated circuits. Okay, so CSIRO, working with some of the universities and taking advantage of great dollops of money that the government was giving out a few years ago, we decided to try and bring some of that very expensive technology to the technology community in Australia and in Melbourne in particular, in a way that is much more accessible. So if you look, this is the heart of that detector that Chris spoke about. It's got a chip here that is the X-ray sensor itself. We now have the fab line in Melbourne that could make that. Around here we have these mixed signal integrated circuits. They're not quite as simple as your average CMOS digital circuits because they're actually dealing with real physical signals. But we're close to having the capability to make those here, although it's actually more cost effective for us to get them from international collaborators. So that's the kind of high-end complex system that where we have ambitions to bring within reach of relatively small SMEs and university spin-outs and the like here in Melbourne. So how are we doing that? This is a new flagship facility that CSIRO designed and with the help of several universities built over the last few years. It's been running now for 2 years. I'm going to get out of the way of the writing. It's called the Melbourne Centre for Nano Fabrication. It's actually the flagship facility and the only purpose-built large semi-industrial fabrication facility in Australia. That's the flagship of the Australian National Fabrication Facility. So there's now this network of CSIRO and most of the Australian universities, typically their electronic engineering department or chemical engineering departments, that are interested in working with, in particular, the medical device startup community. The medical device spin-out community is one of the main areas, also in energy and in a range of other applications where there is a big intersection with the consumer market. Now, that's what a clean room looks like inside. You've probably seen pictures like that. They're quite expensive tools. They're, each tool might be the order of $1 million, and you need a dedicated technician, an experienced technician to operate, and you might need 10 separate tools used one after the other to complete the final component, which you then, like one of those detector chips or electronics chips that I showed earlier. So this facility is here in Melbourne. It's next door to the synchrotron down at Monash. It's an open access facility. Anyone can come in, pay a few $100s, get training, and make anything that they want using a very large range of industrial quality, industrial scale fabrication tooling for things like micro devices, some integrated circuits, although it's not our main focus, microfluidic devices, and so on. So really getting that micro technology. In CSIRO, our main interest is not in the esoteric research that results in Nature papers. Our main interest is in working with companies and end users to create real products. So, just going to talk about quickly, one type of product we're looking at is you've all heard about photovoltaics to convert sunlight to electricity. We want to go and create a whole new industry about using sunlight to create high value added chemicals, fuels and other systems. So great to go straight from light energy to chemical energy. And this is an approach to doing that using microfabricated devices. This is another one where we're actually, it's a part of the early dream of what's called synthetic biology. We're physicists, so we don't like cells, biological cells. They're far too complex and difficult to work with, and they die and so on. So we're actually trying to build chip-scale devices which actually create little micro-scale environments that have very precisely controlled chemical behaviour, where you can do some of the same biochemical processes in biological systems. And we've built, just like integrated circuits, a whole range of different components. This is a delay line which gives the reaction a fixed time to proceed before the next step of the process. This is showing how you can actually do sensing on what's being produced and decide whether or not it should go this way or that way. So we have using electrophoresis to sort the microcapsules. So that's what we're doing.
Gareth really has thrown down a challenge to everyone here who is a maker. Do something, yes, a world-class facility doing what 5 years ago or 10 years ago you need like $1 billion or more worth of infrastructure to do, that you can now lob down to the CSIRO facility and do for a few $100. So how's that for a challenge? Like do something useful with it. I guess my question is, do I just show up on the front door? Like, how do I learn more?
If we've trained our staff appropriately, yes, you can. You just have to have some money.
Okay.
But typically, we would engage through some of the many user groups. So we have essentially all the Victorian universities, some interstate universities, all the major research agencies.
So if someone here who's not part of one of those scenes, has got an idea,
you can contact the facility, either the national facility, ANF, Australian National Fabrication Facility, or MCN, Melbourne Centre for Nano Fabrication, and they will put you in touch. They'll try and understand a little bit about what your idea is, and even if it's something that you haven't worked out anything about the physics or chemistry or biology of what you want to do, but they'll get a sense of what it is and they'll put you in touch with the right people. And it doesn't matter which research organisation.
Questions? Yes. Come back to that question. Any other questions? Sorry, you, then you. Yes, at the back.
Just out of curiosity, how far are we from the development of a true biochip?
A true?
Biochip.
How far away is the biochip?
There are an awful lot of people working on different approaches. There's the synthetic biology approach where you actually assemble DNA and the cellular machinery. There's a lot of progress in that space. I'm not the expert on that, I'm a physicist. There's the systems biology approach where you understand remember a strand of DNA in a cell is just a program, okay? It's got while loops, it's got for loops, it's got if then else statements, and it's executing continuously, okay? We know how to rewrite those programs now. We can suppress some areas, increase others, and change E. coli or yeast cells to become factories of particular proteins that we want to produce, most in the pharmaceutical space. So that's already well advanced. There's a lot of work on what's called lab on a chip, and I guess that's what you're talking about. Mostly in the sensing, the famous Star Trek tricorder area. We've actually made several of those in CSIRO for particular sensing applications, both in medical and in counter-terrorism, chemical and biological warfare applications.
Question?
Yeah, I was wondering, are there any industry feedback loops into the research process, or is it always in the case of trying to create new markets?
I was at a function this morning run by the Academy of Science. We were releasing a report into what's called assistive living technology. So government set the Academy a problem. We're going to have twice as many old people in the future as we have now. How do we keep them productive, and how do we keep them safely in their homes and not in old people's homes, okay? There's a vast array of technology. Everyone was scratching their heads and saying, how do we do that? How do we create business models that gets the end users, the manufacturers and the research community together? And all those learned academy people, I don't think they had any better idea than you do here.
That's encouraging. Last question here.
That's a new project. We started it just this year. So we're working with very simple hydrocarbons at the moment. When we theoretically it all looks good. When we understand the limitations of the technology, it's all about bringing the physics, so managing the incoming light. One of the critical factors of nanotechnology is that it's smaller than the wavelength of light. So it's a bit like surfing. You're managing the energy with systems that are much smaller than the wavelengths you're dealing with, and you're trying to, just like a surf breaking on the beach, you're really trying to concentrate all that energy into a tiny volume to drive chemical processes. So it's early stage technology, and it's looking very promising.
How many of these facilities are there in the world?
It's a good question. There are very many research facilities. Most big universities would have a small clean room. RMIT's got a great one now. UNSW's got one, and so on. This is the only one in Australia that's been built from the ground up with the ability to support up to reasonable manufacturing scales. So we have companies coming and do production runs where they might make enough parts for a month's production for stage 3 clinical trials, for example. It's the only one in Australia like that. There are probably a handful in the US, a handful in Europe.
So this facility can take me a long way down the funding road.
It can take you all the way to the point where you would then go to a fully commercial fab and produce millions of devices.
Thanks very much, Gareth. Gareth Moorhead.